In this lecture, we will talk about how to graph the rational functions. Here there are two functions. One is f of x equals 1 over x. Another is f of x equals 1 over x minus 3. Before we graph the picture, we want to find out the domain. In this case, probably it's easier because domain denominator cannot be 0. Okay, if denominator is 0, we don't know how to calculate 1 divided by 0. Okay, so another way of writing this is from negative infinity to 0. Here is round bracket, so 0 is not included, and then from 0 to positive infinity. That's the interval solution. Similarly, for this one, x cannot be 3. If x is 3, 3 minus 3, so you have a 0. Okay, yeah. So here you may do in algebraic way is x minus 3 cannot be 0. Both sides add 3. You cancel positive negative 3. Then you have x cannot be 3 because 0 plus 3 is 3. So you have that. And then the interval interpretation or solution will be from negative infinity to 3. Round bracket means 3 is not included, and then from 3 again 3 is not included with this round bracket to positive infinity. So that's the domain. Now let's look at how to graph the pictures. You know, for graphing the pictures, if you don't know how the picture looks like, then you need to choose the points. Okay, and then connect all the points with a smooth line. You see right here we start with x cannot be 0, so we start with negative 5, negative 2, 1, negative 0.5, negative 0.2. So you see negative 5, negative 2, negative 1, and then negative 0.5 is the middle point right here. Negative 2 and negative 0.2 is even close to 0. Okay, you have an x value here, you plug in, so 1 divided by negative 5 is negative 0.2. That's y. So x is negative 5, y is negative 0.2. You see from 0 to negative 0.2, very close to 0. So this point. And then negative 2 you plug in here. 1 divided by negative 2 is negative 0.5. So y, this value is negative 0.5. So negative 2, negative 0.5, negative 2 is here, negative 0.5 is right in the middle, so this point. Okay, the third pair is, well, x is negative 1. You plug in 1 divided by negative 1, you have a negative 1. So negative 1 here, negative 1 is on the point. Now here for x equals negative 0.5, you plug in here 1 divided by negative 0.5. You can use your calculator to find out that. Okay, but you know, negative 0.5 is actually 1 negative 1/2, and you flip these two up to the denominator. Here is more details for that. Okay, more details for that. You see 1 divided by negative 1/2, that's 1 times negative 2/1. Because you change the division to multiplication, you have to flip it, and then that's negative 2. Okay, so that's why here is the same, negative 2. Basically, you just flip these two up. If here were 3, that will be a little bit complicated. Here were 3, here were 3, here were 3, then 2 times negative 2 times 3, you would have negative 6. Okay, that's more complicated. Here we just have a 1 upstairs, so you flip this 2 up, you have a negative 2. Okay, so negative 0.5, negative 2, negative 0.5 is here for x, negative 2 is here, so would be this point. Now here negative 0.2, you plug in negative 0.2, 1 divided by negative 0.2, then you have 1 divided by negative 1/5. You know 0.2 is actually 1/5. You actually know that. You see 1/5 is 0.2. Okay, you flip this 1/5 up like this one we did here, so you have a negative 5. Then you have x equals negative 0.2, very close to 0. Y is even deeper down, negative 5. This is y. So this point, negative 0.2 and negative 5, is the one right here. And then you have 1, 2, 3, 4, 5 points. You connect it. Okay, you then have the left-hand side. Remember, x cannot be 0. Okay, you plug in, does not make sense. So x cannot be 0. So this line can be very close to y-axis, but never touch y-axis. From this direction, if you go to the negative infinity, this line can be very close to x-axis, but never touch x-axis. Okay, so here I didn't write it down. Basically, the range is x also cannot be, the y also cannot be 0 for the range. Yeah, if you want this whole thing be 0, numerator has to be 0. But you know, numerator is always no 0, it's 1. So then y can never be 0. That means this line can never touch x-axis. Okay. Now, similarly, you do for 5. 5 is right here. You plug in 5. 1/5 is 0.2. So 5.2 is right here. Okay. You do for 2. You plug in 2 here. 1/2 is 0.5. So when x is 2, y is 0.5. X is 2, y. This one is x. This one is y. This one is x. This one is y. Okay. So when x is 2, y is 0.5. X is 2, y is halfway 0.5. So this point is the second point. Now x is 1, you plug in 1 divided by 1, you have 1. Okay. So here you have 1, 1. X is 1, y is 1. So this third point. Now another 2 points. You have 0.5. You plug in here. 1/0.5 is actually 1/2. Flip 2 up. So you have a 0.52. Okay, 0.52. So 0.5 is for x, 2, y is 2. So 0.52 is right here. Okay. Now, if x is 0.2, you plug in 1 over 0.2 is 1 over 1/5. Flip 5 up, you have 5. So 0.2 is quite close. This is x, quite close to 0. And 5, that's y value right here. So you can connect all those 5 points. Okay? Then you will get the left-hand side of y-axis. Again, you can see right here, 1x goes to infinity, bigger and bigger. This curve will be very close to x-axis, never touch x-axis. Similarly, for x goes to 0 from the right-hand side, from the positive side, this line can be very close to y, but never touch y. Okay, because x cannot be 0. Then there is no corresponding y here. That's basically the picture, this one, for 1 over x. Actually here we chose 10 points. You see, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 points. Together 10 points. Okay, and here we call this x-axis is horizontal asymptote. If it's horizontal asymptote, y is 0. That's the equation. Similarly, y-axis is called vertical asymptote. In this case, x is 0 is the equation of y. Now, that's the graph, this one, for that. We want to look at this one, 1 over x minus 3. Okay. Okay, let's choose the points. Right here, I also chose 10 points. The first one is x equals -2. The reason I chose -2 is because if I plug in -2 here, -2 minus 3 is -5. So I know, 1 over -5 is -0.2. So then we have a -2, -0.2. Okay, so I know this point. Okay, -2, -0.2. So x is -2 is here. Okay, and y is very close to 0, is -0.2. So this is the point. Okay, this one. And then 1x is 1. You plug in here into the equation. X is -1. You plug in. 1 minus 3 is -2. So 1 over -2 is -0.5. See here? So here 1 acts like -2. You get the same value. Here -2 acts like -5. You get this y. The same y, you have a different value x. Okay, that's the first 2 points here. Now you plug in 2. 2 minus 3, you have a -1. 2 minus 3, you have -1. 1 divided by -1 is -1. So you have a 2 -1. X is 2, y is -1. So x is 2 is on the positive side, y is -1. Okay, x equals 2, y equals -1. Yeah, previously we have x equals 1. 1 minus 3 is -2. So we have a 1, -0.5 for this one. X is 1 here, and y is -0.5. I should write right here. Okay, that's the third one. The fifth one, again, 2.5, you plug in. 2.5 minus 3 is negative 0.5. And 1 divided by negative 0.5, we know is negative 2. So here 2.5 acts like negative 0.5. 2.5 is right here. This is 2.5. Okay. And then here you have a negative 2. So down here, negative 2 is right here. So 2.5 negative 2, this is the point. 2.5 negative 2. Okay. Now the fifth one, 2.8. 2.8, you have 2.8 minus 3 is negative 0.2. 1 divided by negative 0.2 is negative 5. Okay. So 2.8, yeah, acted like negative 0.2. So for the same value, negative 5, you need 2.8 for x. Okay. Great. So where is that? 2.8 is right here for x. Y is negative 5. Okay. So you see here is negative 5, negative 4, negative 3, negative 2, negative 1. Here is 1, 2, and going up 3, 4, 5. Okay. Now you have 5 points now. 1, 2, 3, 4, 5. You may connect it. 1, 2, 3, 4, 5. Connected. Okay. How about 0? X equals 0. This line actually, this curve actually goes across y-axis. You plug in 0 here. You see, if you plug in 0, 0 minus 3 is negative 3. So 1 over negative 3 is negative 1/3. Okay. So you have a 0, negative 1/3 here. That's x is 0, y is negative 1/3. So you have this point, 0, negative 1/3. So again, you see, the picture looks like that. Okay. Now similarly for the positive side, that's probably easier. You see 8, you plug in. 8 minus 3 is 5. 1 over 5, that's 0.2. Okay, so 8.2, 8 is right here. That's x. Y is 0.2, is quite close to 0. So 8.2, you see, is this point. Okay. You plug in 5. 5 minus 3 is 2. And then 1/2, that's 0.5. So 5.2. Okay, 5.2, 5 and 5.5. 5 and 0.5. That's right here. X is 5. Y is 0.5. Okay, so that's this point. So here 5 x like 2. Okay, 5x like 2. And then x equals 4. 4 minus 3 is 1. 1 divided by 1 is 1. So here we have 4, 1. Here is 4. X is 4. Y is 1. So this point, 4, 1. 4, 1, 4, 1, this point. Now keep going. 2 more points. X is 3.5. 3.5 minus 3 is 0.5. Again, you do the calculation this way. 0.5 is 1/2. Flip 2 up. That's 2. So 3.5, 2. 3.5 is right here. 2 is 2 units up. So 3.5 2, this point. And then 3.2 minus 3, that's 0.2. 1 divided by 0.2 is like this one. Okay, so that's 5. Yeah. And then we have a 3.2 plug in, we get 5. 3.2, here is 3, so slightly to the right. And then 5. 1, 2, 3, 4. 5. Even higher. 1, 2, 3, 4. I need to put the point here. Let me put an arrow here. Okay. Shows that was the point. Is that right? 1, 2, 3, 4, 5. Yes. Okay. That's right. Yeah, here was 2, 3, 4, 5. Yes, this point. Not the one here. Okay. Now, here again, 3.2 acts like 0.2. Okay. And 5. Yeah, in order to get 5, x here has to be 3.2. Now again, you can connect 5 points on the right hand side. You can see clearly here is that this branch is like this branch. This branch down here looks like this one. Again, here this curve can go as close as you wanted to x-axis, but never touch x-axis. Go from the right hand side to 3. This curve can be very close to this dotted line, but never touch this dotted line. It's because x cannot choose 3. Remember, 3 is not in the domain. Okay, so this dotted line is like y-axis. We call vertical asymptote. So here x minus x equals 3, this one is the vertical asymptote. Okay. Similarly, x-axis is the horizontal asymptote. X-axis has equation y equals 0. And then vertical asymptote has x is a constant 3. You see. How did we actually know vertical asymptote? That's quite easy. You see, the 0 point for denominator, that will be the vertical asymptote. Remember that. 0 point for denominator. What is the 0 point for x? That's x equals 0. Okay, so that's why here is y-axis, and here is x equals 3. Please also remember, you can see clearly here this dotted line is 3 units from y-axis. So another purpose I want to for this example I want to show you is that this picture actually you can get is 3 units minus 3 is 3 units to the right. You'll get this picture. Okay, 3 units to the right. And here are the details. You can see -5. Here is -2. You get the same value. Okay, so in order to have a -0.2, -0.2 here was -5 for x, but here is x equals -2. See that? So between -5 and -2 is 3 units to the right. And here are all the details for the calculation. Look, 5, 8. Okay, in order to get 0.2 for y, you see 0.2 for y. Here is 5, because you plug in 5 here, 0.2. So you see 5.5 and 0.2 is this point. For the same level of this point, x needs to be 8. 8 minus 3, so is 0.2. So the corresponding point is 8 and then 0.2, and here is 5 and 0.2. So the difference between 5 and 8, you see, 8, 5, that's 3 units to the right. Okay? So when you see this kind of picture, you go from there. Minus 3, 3 units to the right. If it were plus 3, you can do the same calculation. It's going to be 3 units to the left. Remember that. Okay, this is the things we did before. Okay, please consider this example, review this example. We probably will use this example a lot. Okay, and then I'll see you next time.